Is Laura Gomez-Rey, and this is my Physics 2212 lab on lines of charge. Alright, so just like an executive summary of everything that we're going to be talking about, I'm going to go through an introduction kind of explaining everything that we need to know for the experiment, the computational model of the code on GlowScript, and the experiment of the results after inputting all the numbers, and then some observation questions for the end. Alright. So beginning, there's some key ideas that we need to know, including Coulomb's law, which is going to help us find the electric fields, and then actually knowing how electric fields work, the force due to gravity, which we will need because of the hanging tape. We'll need to know the gravity of that and how it's affected, and then line charges, because that's how we're going to actually calculate all of the data in this experiment instead of doing point charges, and then an electric field superposition, because basically line charges is getting all the point charges and kind of adding them all together. So that's why we're going to need that, because we're going to have to add up all the E fields together. And then relevant formulas that we're going to need to know are Coulomb's law, E field of a rod, the force due to gravity, force, E field of an actual point charge, and then just as a reminder, 1 over 4 pi E naught is equal to 9 times 10 to the power of 9, which is in all of the equations here, so we're going to need to know that for the formulas. Alright, and then this is the diagram of the actual experiment that we did. Here are all the measurements and the widths and everything that we needed, and you see how there's a top tape and a bottom tape, and how the top tape will be affected by gravity. Alright, and then we actually need to find Q before setting up the computational model. I set the magnitude of the gravity and electric forces acting on the top tape equal to each other. And then I use the formula of the electric field of the rod, which will represent the line charge. And I did this by equaling force of gravity equal to force of electric. And that's how I found my Q after doing some calculations. And then we can actually go ahead and calculate and set up our computational model. I defined a function to calculate the electric field at a given location due to the specified charge. And then we go into the actual computational model, and this is where I split up the tape into multiple line charges. And then I was able to find the electric field due to the point charge on the bottom tape for each point charge on the top tape. And then after that, I had to go ahead and add up all the electric fields to find the net electric field at every point charge in the top tape, because again, we have to add up all the point charges to get the E net. And then there was a program output. I ended up setting n equal to 100 because, and I could have done more, but the thing is that the higher n number you have, the more accurate it's going to be, because there's the more point charges, and the more point charges you have, the more accurate it is to being the actual value, which is basically like taking the integral more precisely. And then the green arrow is the net electric field of all of them. And then for our results, as stated before, this is the Q that I calculated, which is 5.71 times 10 to the power of negative 8 coulombs, and then the force electric and the force of gravity, which the computational model helped me find. And some assumptions that we had to do is that we did not take air resistance into consideration. We also treated the tape as a line charge instead of a point charge. This is because it was going to give us more accurate results, and then we assumed that the charges in the two tapes were going to be the same, which is what helped us find the Q and the overall experiment. And some observational questions that we're going to have is, what if we had modeled each tape as a single point charge? Well, in this case, a point charge is much smaller since it only considers the interactions of a point charges with each other. And then the distributed charge models considers the interaction of every small distributed point charge in one rod to every small distributed charge in the other rod, which basically sums up all the interactions to find F net, which is larger as it considers all of the interactions together. And then the estimates differ because the estimate of the charge produced by the distributed charge model is likely to be closer to the real value since it more closely resembles real world conditions instead of just using a point charge. Thank you.